device that is what are all the spare parts in that device I have shown, and I have explained about all these terminologies. Okay, so this also works under the principle of velocity modulation. So that one you have to keep it in your mind. Yeah. So in today's class, after class is over, I will upload this ebook. You can see ebook of microwave engineering. This is your prescribed textbook. In this, all contents will be there. But if you go through it, it have big theories will be there. So just for your reference, okay. So you should not have awareness of the textbook. Only PPT alone you are looking on. Okay, you have to know awareness of the textbook. What is the textbook for the each and every subject you should know. Okay, so that is the main objective. So you should even if you are studying in this digital world, okay, you have awareness of the textbook. Okay, so whenever you go for any industry, that the textbook will helps you to, even if you not read fully, they will ask what is the textbook author, or what is the edition you have used, which year publication you have studied. Okay, sometime in core companies they may like maybe in media they will ask or not, I don't know, but especially in electronics company they will ask this things. Okay, okay. Uh, okay. So in velocity modulation process only the bunching of electrons has been taken place. So there is three different types of electrons we have studied. One is a slow rate electron, early electron, and another one is the moderate electron or reference electron. Okay, so that one based on those two, three type of electron only, this process has to be mainly focused. Okay, so let me see where I have stopped. I think this thing I have taught in the last class. Yeah. Still, we not completed the TWT. After that, we go ahead with the magnetron. Okay. So the beam velocity is greater than the field velocity. The field velocity is also called as the current field or electric field. Okay. So you can see the statement as the DC voltage velocity of the beam is maintained by slightly greater than the phase velocity of traveling wave. More electron faces the retarding field than accelerating field, and a greater amount of kinetic energy is transferred from the beam to the electromagnetic field. So you know the structure. Okay, once again I will show the structure of this. Yeah, you can see when the electron, sorry, when the input signal is comes from this electron gun. Number one is the electron gun, and number two is the inlet of sending. This is one cavity, ventral cavity. This is the cathode cavity. Once the RF input signal is comes inside, okay, so here the flow of electron also starts. It will tends to move in the this helical structure. Okay, normally this helical structure is a normal conducting medium. Once the conduction happens, it looks like a solenoidal effect. You may study like a solenoidal effect in your physics. Whenever the power supply is applied or potential applied to this type of conducting element, okay, it will be get magnetized. Okay, when electric field is down or zero, then magnetic field also becomes zero. Okay, so that is called as the magnetic field. But here we not focus on the magnetic effect. Okay, the signaling is goes towards this, and it becomes very reddish. Okay, in late shop and all you may see like that is when heating that device, it looks like very reddish. Okay, that has the heavy temperature. We cannot even touch. If we touch, we also get harmed through that device. Okay, So in similar way, this will be works. Okay. So what only they are telling that beam velocity is very great. So it will be significantly send their electron very fast. Um, so we are in a graphical representation in last class. I showed that it will be more like that, but it is moving very instantly, and it will take quick response in that case. Okay, why attenuator? Okay, in most of the microwave workbench setup, we need the attenuator. Okay, so why attenuator? The word attenuation is nothing but the loss. Okay, attenuator is placed over a part of Helix on the midway to attenuate any reflected wave generated due to the impedance mismatch. If I go to the empty hall and I am shouting, what happens? The echo will come. In similarly, in middle of this helical structure, okay, some signaling may be bombarded with each other and it will be get reflected back. Okay, due to the impedance mismatch. Okay, so this will be happen. We have to avoid this type of reflection effect in your transmission line. It is placed after a sufficient length of the interaction region so that the attenuation of the amplified signal is significant compared to the amplification. So this type of interaction will continuously happen. Okay, so that attenuation of the amplified signal is insignificant. That is, even then that attenuation is there or mix up with your input signal, it is negligible. Okay, it is negligible when it get amplified. Okay, so we some minimum quantity of the noise will be there. Okay, that's the point here they are maybe telling. And what is the specification of this TWT device? It is 3 gigahertz and higher, and the bandwidth is about zero point 0.8 gigahertz, and the efficiency of this device is 20 to 40%. Power output up to 10 kilowatt average, and the power gain up to 60 dB. Okay, so this is the difference of TWTA and the Klystron amplifier. Okay, so both the device are what? Klystron amplifier and the TWTA are O type only. So O type means it is a linear device, but the cavity structure alone varies. Due to cavity structure, it is Klystron amplifier uses the resonant cavity for input-output circuit, whereas TWTA uses only non-resonant wave circuits. Okay, and the Klystron amplifier has a narrow band devices, and TWT has the wide band devices. Okay, so the application for this is satellite communication. So for medium type, it is used for power satellite, and higher, it may be used as a power satellite transponder output. Okay, so this is the application of TWT. So you may ask one question that the satellite is sending the signal. So we know the term satellite alone. Okay, the satellite is positioned in the geostationary orbit. Okay, so Earth is look like a global. It look like a elliptical structure. So according to that globe, okay, so the satellite has been launched into the geostationary orbit in the space. For this, some laws will be there, maybe in a satellite communication in detail you will study. But our objective is that most of the operating frequency in range of microwave. So then only we can, it will be broadly communicated. Even a cricket program is telecasted. Okay, so we are getting information as quick as possible in our smart mobile phone, laptops, and televisions. Okay, quickly. Okay, so but the thing is that some delay will be there. Even the researchers are doing this type of avoiding this delay, but still this delay is happening. Okay, even in my home and near home, the same cricket program is watching. Okay, in my home, the advertisement is going on. In next home, the advertisement get over and it will start. Okay, such type of delay you also see in real time. So that is the challenging task, but still that problem is not overcome. Okay, so this is called as the traveling wave tube. Mostly this traveling wave tube is used for the wider frequency band so that it can be used for this type of satellite communication. And also it can also used for the radar communication also. Okay. I hope this topic is interested to you. Maybe in your app, okay, there are different types of devices. You can take any one device and just see the some tools may design the model of the structure. Some tool may already designed only the matrices alone. You have to change and you have to take a simulation. Okay, in some software only the modeling alone will be there. Okay, it will be interesting that Play Store app. So last year batch students has been did and they have given a good feedback. It is very understand. Okay, in real market, how this has been using in the real time platform. Okay, so that one is completed. Let me go with the next topic. I hope up to this topic, no one having any doubts. If you have anything, please you can. I will stop here for 1 or 2 minutes. Okay, so that you can pick up what all the things you have seen up to today's class. If you have any queries or any doubt, you can ask. I think I will take positively in your side. No doubts in your side. If you have anything, you can ask me in personal also. So here also I have separate PPT also I have put some hint points alone. Those points you can look in up and I can see the construction diagram, everything I have clearly mentioned. No need of any formulas. Just look it on. Okay, what are the things I have given and the mode calculation. So mostly the mode calculation you will do it in a real practice in the laboratory. Okay, since you not have the laboratory, okay, so you're not doing this type of experiment. Okay, let me go with the magnetron. So magnetron. First of all, I will go with the magnetron in your textbook so that it will be really good in your textbook. Yeah. So can you able to see this textbook, e-textbook?
Yes, sir.
Yeah, thank you. Microwave crossed field tube. So the M is nothing but microwave crossed tube. Actually, that device is also called as, sorry, the previous one is called as O type microwave linear field tube. Okay, this is a cross field tube. Okay, you can see how the structure. So some introduction has been given. There are many types of cross field devices out there. You can see one is a cylindrical magnetron, biaxial magnetron, voltage tunable magnetron, inverted magnetron, a forward wave cross field amplifier, backward wave cross field amplifier, backward wave cross field oscillator. Okay. So this many types are there available in this cross field tube. So what is the cross wave tube? So I will show one thing. Suppose this is one tube you are telling. Similarly, another tube is also there. So whenever it is crossing and it is bending, okay. So please imagine the two twins. Sorry, the two threads or two thick threads has been winding up. So when the two wires are winding up, how it will be like? Okay. So like that only this twisted pair of cross field tube will be there. Okay. There are this type many types are there. Actually, the magnetron, the word magnetron, is nothing but to improve. Sorry, to improvise the field in different pattern, in a different pattern. Okay. So based on the shape, you can see cylinder. So how the cylinder shape will be? Cylinder. You can just imagine it is a thick pen. It is a one type of cylinder I will tell with equal diameter or equal radius. Okay. So just to see this device. Okay. So this is a cylindrical type of cylindrical pattern. So how did the base and how did the top view look like? Okay, it's like a circle. Okay, in between only from the wall, the radiation or of signal will be radiates. It will be circulate over to this geometry. Then it produce only circular pattern. Okay. So similarly, the coaxial magnetron, I can see introduced by the principle of integrating a stabilizing a cavity into the magnetron geometry. Okay, magnetron geometry. Okay. So like that, many types will be there. We no need to bother about all types. In our syllabus, only cylindrical magnetron will be there. Okay. Cylindrical magnetron. You can see the same thing what I have mentioned in the descriptive. So that has been given in the flow graph. Okay. So magnetic oscillator or magnetron oscillator. So I have given a few different types of the oscillator in your PPT also. I can look at. Yeah. It is a split anode magnetron, cyclotron, frequency magnetron, and traveling wave magnetron. So each one has their different characteristic. This type of actually first type you can say this type uses the static negative resistance between the two anodes. Okay, two anodes. Mm, so here in this structure in split anode, the two anodes will be there. So that has the static negative resistance. Usually in this type of microwave gadgets, most of the device will be satisfied with the negative resistance property. So in that split anode magnetron is one of the devices. Okay, similarly cyclotron frequency magnetron. It influences the synchronous between alternating component of electric field and periodic oscillations of the electron in a direction parallel to the rotate. Similarly, the traveling wave magnetrons, this type depends on the interaction of electron, traveling electromagnetic field of linear velocity. So this type of thing is called as the magnetron. So you can see the geometry, it will be look like this. And previous classes I have shown one video also. That is in reality how that mechanism has been taken place through animation video I have shown. You can see how the magnetron wall will be there. Okay. The cross-sectional view has been shown. The wall has the anode polarity, where at the mid of that has the negative polarity or cathode. Okay, at the end you can find the end hat, so that will be properly grounded, so that there is no damage with your gadget. Okay, once the applied of potential, what happen? The electron will start move, and then what happens is that mm, the force experienced inside that wall. Okay, force experienced in the inside of the wall. You can see the diagram. This is the wall. Okay, the circle is the wall, and inside the thing is that the cathode. So your electron will be moved like this. You can see how it is going on. Okay, at each side it will be strike on that gap, and it will be going in that free space. Wherever gap is there, it will goes with the free space with a proper acceleration and velocity. Okay, you can see this diagram. You can see this thing. Some cut off, some cutted region will be there. So this once the electron is going inside, it will be covered. First of all, it is very covered, and it is there is no noise will be added along with that. So it will be properly protected with this type of waveguide. Okay, so all utilized input signal will be sent it back to the outlet as a RF output signal. So the efficiency more in the magnetron only, and in reality, it will be available in the industrial sector. Okay, so due to some other sound component, it may tends down to reduce the level of efficiency or performance. Okay, so this is the specification detail of your device. So that is output power and the efficiency. You can see what is the value obtained. It is the equivalent circuit. You can see it is the equivalent lumped circuit they will tell. It contains the capacitance, inductance, and the resistance. Okay, it is one lumped unit. It is the equivalent lumped unit of the specified device for your structure. Okay, for your structure. Okay, so in your textbook there are a lot of equations and a lot of things will come. No need to read this thing. Okay, it will in reality it will be like this. It is one model. Please see, it is one model photograph of Liton L5080 magnetron. So the magnetron part will be at the middle one. Okay, the entire unit is not a magnetron. This middle part only has the magnetron. Okay, so this magnetron, this magnetron helps us to both the oscillations and the amplification. Okay, that's just you can remember the few points which are listed in the PPT, and just look into the geometric structure, and you should know the mechanism of each and every device. Okay, I hope this one is clear to you.